Maybe it goes like this from far away. Maybe. Oh, might be a lever. I get it.
All of these are connected, and then it connects to the batteries.
I like working on robotics and using mechanical arms and flowbotics and effects all at the same time and trying to get them to talk together.
Learning problem-solving skills that Project Lead the Way curriculum teaches you is going to help you in whatever field that you go through.
You're working on something huge and you're making a huge impact.
When you walk into a Pltw classroom, what you find is tremendous excitement and passion, not only from the teachers, but from students.
Project Lead the Way is great in that there's so much hands-on. Every activity we do gives the kids the chance to have a more in-depth understanding.
With like your biology class, you kind of hit certain points, but then with the biomedical classes, you go more in depth with diseases and heart functions and body functions.
Project Lead the Way has 5 programs, all of which are designed to prepare students for post-secondary education and careers in the global economy. Launch is for students in kindergarten through 5th grade, designed to capture their interest in and spark a lifelong passion for math and science. Our Gateway program for students in 6th through 8th grade is a series of 9-week units that continues to engage students' natural curiosity and problem solving and shows them the relevancy of math and science in their lives. And we have 3 high school programs. The engineering program is a series of full-year courses that gives students a deeper look at the engineering design process and teaches them to think critically, solve problems, and to collaborate. In our biomedical science program, students explore human medicine, public health, human body systems, and medical careers. And finally, our computer science program, which is designed to build student interest and engagement in computer science, develop computational thinking skills, and explore topics like programming, data mining, and cybersecurity. When we think of the STEM pipeline, in science, technology, engineering, mathematics, it's clear across our nation that we have a shortage.
This is where the jobs are. This is where the future is. There's a national interest. There's a national security interest. There's just a ton of reasons to get better in science, technology, engineering, and math.
We want students to understand that when they leave high school or they go into college or post-secondary education, they go to the workplace, they're not going to find themselves isolated and as single problem solvers, but rather as group problem solvers.
They're not given a textbook answer. There's not a textbook lab to follow. They really have to think of their own problems and their own solutions.
We learned how to calculate the stress throughout every part of a bridge. That's how we determined how to build our bridge. We knew we had to put support right here, so that it didn't collapse right away.
We have to think differently about the way we engage students. So we spend a lot of time training teachers, helping them learn to teach differently.
We have teachers that go to summer training every year and they take the Project Lead the Way courses. When they come back to us, they're teaching us current stuff that's in the field today.
This is a big component of the course, working through this and practicing it, asking each other questions and talking through it. Hopefully we're going over the questions the students will have.
Our students do better, they persist, they outperform, and most importantly, they get excited about learning.
All of our students who have participated in Project Lead the Way, their tests on ACT are through the roof.
It's also going to help them perform better in college and later in life because you're introducing skills that will be beneficial to them.
I already know that when I go into college, I want to jump right into engineering. I definitely feel like being exposed to it for 4 years, I can't go a year without it.
Education is complex. That's why our partners are so important. Our university partners in helping with outreach and professional development of teachers, engaging with our students, recruiting our students, but also all of our corporate partners. And we have both national partners and partners across America that understand the importance of this work, but have also recognized how important Project Lead the Way is to America's economy and improving educational outcomes for all students.
And Project Lead the Way, it combines Cargill's philanthropy with the active volunteerism of our employees in a number of locations. So in that regard, I get very excited by the way in which Project Lead the Way carries out its work.
The students coming through our program have developed critical skills and knowledge that are highly desirable in the marketplace. So that's why universities and companies are recruiting our students.
They're more successful. It works.
It's the best package I've ever seen.
Project Lead the Way has influenced me because if I would have never taken classes like this, I would have never had those options for me. I would have never had that experience.
Taking these type of courses is a huge advantage.
I'm so thankful for having such a good program like this.
I'm so happy that I found PLTW.
Now it's definitely one of the things I'm thinking about doing as a career because I really like this class and it's a lot of fun.
It's definitely something you should take. It's a life-changing experience.
It used to be that you would design under one roof and then manufacture under one roof. What we've seen is a lot more specialization. Expertise has become fragmented, and as a result, each of these people need to coordinate and work together in the design process. They can be across the state, across the country, across the globe. And so people need tools to be able to interact and communicate. We took the opportunity to look at how the CAD world had evolved, how product design had evolved, and how the computing infrastructure had evolved. And we decided to hit the reset button on product design software.
Onshape is building a new generation of CAD, one that's designed for teams to use. Everyone on the team can use it anywhere, on any device, anytime.
We're capitalizing on the platform, the cloud, mobility, and redesigning essentially what CAD is to help people design products faster, easier, and more affordable.
20 years ago, when we built SolidWorks, we built CAD on the modern computing platform, the Windows PC. It runs only on that computer. When it comes time to work as a team, users have to use all these schemes to copy files, check in, check out. It's kind of a hassle and it costs them time. Today, CAD still runs on that Windows PC, but people are used to using their phone, their tablet. People are used to working on multiple computers and going into a web browser.
Teams are built up and torn down quicker. There's a lot more collaboration. Tends to be a lot more contractors, a lot more consultants.
And so the rest of the computing world has changed a lot, but CAD hasn't. And it's time for CAD to evolve.
You know, users, they're like all of us. They're tired of trying to figure out what's the login password for the data vault, because I don't use it all the time. And when I get the assembly, all the links are broken.
License fees, installations, license managers.
Do I have the right version of the part or the right version of the assembly?
I visit CAD users. Years ago, I talked to them about modeling cool shapes and cool products. But in recent years, when I visit users, they're talking about all the hassles of CAD. And it's time to get rid of all that.
Users today expect that we should just be able to access information and share and work with other people real time, much like the way that Google does for working on a Word document. We've done that for the CAD world.
We get to collaborate on the same geometry, which was never done before. We have found ways to break down our modeling paradigms, our assemblies, our models, our features, so that multiple engineers can collaborate on the same feature, which was never done in CAD before.
The cloud is really a transformational platform.
We put the CAD system and the CAD data in one place in the cloud, and one master copy of the CAD data that everyone can access simultaneously from anywhere through any device. So there's never any copying of a CAD system, and there's never any copying of CAD data.
When we're working on something simultaneously, you see visual cues to understand what part of the model you're working on, what part of the model I'm working on.
Even people who see Onshape once will say to me, "Hey John, can I get a copy of Onshape?" And I say, there is no copy of Onshape. I don't have to send you a copy. You can log in from any computer. You log in through any web browser and you have access to the whole system. Even if you have an iPad or a phone, you can use Onshape.
It can be used by the single user working at home, the small design professionals, small teams, through to some of the largest manufacturers in the world.
CAD users, product designers, engineers, they don't sit at their desk all day. They're in meetings, they're moving around, they're at the coffee shop, they're having lunch, they're home thinking about it on the weekends. Wherever they are, whenever inspiration strikes, they should have access to CAD, and with Onshape they do.
browser technologies, mobile technologies, and cloud technologies are converging and giving the capabilities to build complex system like ours.
What we are doing here is very forward-thinking and innovative, and we have the team that can achieve this.
We've got people who are the most experienced, talented, smartest software engineers and CAD engineers that I've met in my career.
And so it's serious CAD, it's serious design software.
You'll get products done faster by teams, and you'll get them done better because they have more time to spend on engineering. And finally, I think engineers and designers will have more fun. You know, Onshape's just more fun to design with.
The best technology-based tools in the 21st century classroom are the highly interactive ones. Digital whiteboards, computers, and tablets all allow students to explore, create, and develop the problem-solving skills they'll need in a world growing more dependent on STEM-based technologies. The Dremel 3D Idea Builder takes that learning to a whole new level. Start designing from scratch using a program like Autodesk's Tinkercad, or download any 3D print-ready models from Dremel3D.com. Using Dremel's intuitive, easy-to-use print preparation software, you can move, rotate, and scale models before printing to maximize the quality of your project. Students become completely engaged when they integrate design thinking skills into their creations. 3D printing teaches students through problem-based learning and experimentation, encouraging them to refine their designs in an ongoing process where they can see the tangible results of their critical thinking.